Yesterday, we mainly focused on Python string data types. So we mentioned the notes actually here. Let me just open that one. The notes are here. So maybe we can just take like 5 minutes. We look into the most important aspects we did on strings. So I think I can just basically go through this these notes here. Then on your free time, maybe if you're not able to attend the class, you can actually go through this notebook here and through the video that we have for the same. So just to recap something about strings, we said that strings are basically data types that are used to represent characters in a sequence, okay? So, for example, you can have words. So word is made of sequence of character. You can talk about sentence or any textual data. So we say that string they must be either enclosed using the single quotation marks or double quotation mark or triple quotation marks, depending on the operation. So we add the single line strings that we call the basic strings, and you also have the multi-line strings. And now, finally, we mentioned some of the methods. So methods are basically some functions that you can call to a data type that you can actually use for manipulating and interacting with strings. So for example, we have lower. If you want to convert every character to a lowercase, we have uppercase. The same when you want to convert all the characters to the uppercase, we have replace. We have the split, and so many more. So these are methods that allows several tasks like case conversion, placing characters, splitting a string into a list, and also string formatting. So that is what we did yesterday. In case there is a question with that one, please make sure you have booked for the consultations today. So in our today's class, just like we had introduced Python data types, let me go through that document again. Sorry. So these actually are outlines. So far so good. We have done Python numeric data type. I hope there's no question there. In case you have a question, make sure you have the consultation booked, sorry. And now we've already done Python string data type. So we're actually going very, very well. If you're able to understand this aspect, then we are in the right direction. So for today, now we want to introduce Python sequence data types. And specifically, we are going to talk about Python list. And let me remind you something. Python list is one of the mostly used data type for data scientists and data analysts. So they normally interact with Python list a lot using a library called NumPy. So if you really want to understand the Python NumPy library, then I think this should be the right lesson for you today. So as you're going to notice, for you to understand the Python list data types that you want to do today, then you should first understand the first two. Because you can have sequence of strings, which are the text data type, or you can have sequence of numerical data type, or both. So for us to now differentiate the two, then we should first understand what are the numerical types, what are the text type, and then now we can put them in a sequence. So for today, we are actually here, we are talking about Python list. Later, we talk about the tuples, and we talk about the range. Then from there, we should have exhausted all the Python sequence data types. Then now we move on to sets, dictionaries, and Boolean. So this actually, we can do them within a day, which most likely will be tomorrow. So for today, because lists are also widely used, same as strings, I want to focus on it for this lesson today. So if you are ready and you've actually clicked on all the aspects that we've actually added, please now click on Python list data types. We do them in details. And then from there, you can also open the notebook that have actually, the link to the notebook that have that I've actually pasted below there, so you can just open it up here. So this should be the guide notebook that you want to use. And also, you can open a new notebook, just like we did it yesterday. Just open a new notebook. On the side here, just call it Google Colab. Google Colab. And then you can open the new Colab here. So this is actually our guide notebooks. It's what we are going to follow together. It's quite a lot, but it's quite educative enough. It's what we're going to do today, one by one. Then from there, we are also going to do some practice notebook here. I want to create a new notebook here. So the notebook that you're actually creating, I hope I've shared the link. If not, then I think I need to reshare it here on my chart. So let me just do the same. Go to the chart. I paste the link. So this should be now the notes that you are going to follow. These are the guide codes that you want to try out. And then this one, you can actually name it Python lists. Python lists, list data type. So just call it Python lists data type. Python lists data type plus practice. So like I had mentioned yesterday, because you're going to use this list a lot, please make sure you now try to practice on them, just like we did some class practice on Python string data types. So we want to do the same for Python list data type class practice. So these are the notes. These are the codes that you want to follow. These are the notes that you want to start with. And then here, this is where you want to do some more practices so that now you're able to interact with this Python list in a more effective manner. So I would wait for you to do that setup. I can give you 2 minutes for you to have the setup done. Make sure just have a blank notebook where you're doing your class practices here. Have these notes here, where this is what we are going to follow together. And then be ready now to have the notes. This is where we want to start with, so that now we're able to understand what are the Python list data types. Why do we say they are the mostly used data types in data science and data analysis projects? And how do we start? So let me give you the 2 minutes. We start exactly 9:18 by exploring now the notes to do with the Python list data types. So that is where we want to start. So let me give you the 2 minutes to do your setup ready. In case you've not opened all the notes here, then you can do so. Just do so. And then now I'm sure we are going to now to move in the same direction. Okay. Yeah, so it's already 9:18. I can see others are already ready. So let's start. Let's start together. So I hope now you're not behind. Let's now go together. So we can actually say that the list data type is Python. Let's just look at this one here. the list data type in Python is used to store ordered collection of items. Okay, so a list is one of the mostly versatile. So if I say versatile, it is used in different aspects and commonly used data type in Python. The reason being is that it has an ability to store multiple elements of different data types. So with Python list, now you have the ability to store different data types within one variable. For example, you can decide to store integers, you can decide to store strings, you can decide to store even other lists, okay? So also, so one thing you've noted is that lists store ordered collection of items. Another thing is that lists are mutable. So there's someone who asked this question yesterday. Now we want to differentiate between what do we mean by an immutable data type, something like a string, and a mutable data type that now we have a list. Meaning that, so if something is mutable, then it means that their contents can be changed after they are created. Okay, so we'll demo that one very fast. And we are going to see that mainly we have two types of a list. We have a basic list. We have a basic list where we have a list by defining item inside square brackets. Yeah, with each item separated by a comma. That is very important. So remember, if you want to store item in a basic list, then each and every item is stored inside a square brackets. This one here, the one that has been shown here. And then you make sure that each item in the list is separated using a comma. A good example is something like this one here. This is actually a list because I have stored a collection of numbers, 1, 2, 3. I've stored a string. I've even stored a float. So the item inside the list can be of any mixed data type, and then lists can be accessed using something we call the indices. So we use the indexing operation to access items within a list, okay? So we are going to note later that Python indexing starts from 0. Please always keep that one in mind. Even for the strings that we did yesterday, we saw that if you want to access characters within a string, then you access them by their indices in such a way that all the indexing starts from 0. So the first element that you add inside the list will have an index of 0, okay? So then from there, we can actually say that list can be modified by adding, removing, updating, using some methods like append, remove, insert, and so many other ones here. So before you even open these practice notebooks, let's first note some very, very important aspect about Python list data type. So just press Control, then you press question mark. I think I mentioned that one yesterday. You press Control, then question mark. Then here we are actually talking about the Python lists data types. Python list data types. So we have seen some of the properties of a list. So let's start with number 1. We've seen some of the properties. So let's talk about the properties of a Python list. Properties of a Python list. So let's start. So I think I'll start here, control question mark. Based on the notes that we've had, A is that they store a collection of data, not even data of items, collection of items. They store collection of items. So please remember, these items could be, it could be integers, it could be floats, the one we've done already, floats. It could be complex numbers. We can store a collection of complex number. It could be strings. It could be even other lists. other list that you're going to call a nested list, other list, that one, other list. Then the collection of items are stored inside. So please always keep that one in mind, inside a square bracket. Square bracket. So that is the first property that we have noted together. That if you want to identify a list within your code, then the items will be stored in such a way that we have a collection, that then we have them inside a square bracket like that one. Okay, that is the first main property of a list. Items are stored in a collection inside a square bracket. I hope that one is okay. Number two, before you even write the codes, let's first understand them in more details. The second thing I've noted is that items within a list, items within a list, items within a Python list are ordered. They are ordered. Okay, please keep that one in mind. They are ordered. So what do I mean by items within a list being ordered? That means that each item is assigned. So if I'm saying to assign is to be given, like it's provided. So it's assigned a numeric value starting from 0. So please remember that one. Please always keep that one in mind, that if you're dealing with a Python list, then each and every item has an order in such a way that we are actually providing numeric value to each item starting from 0. So later we're going to see that. Let me just add something here. This will be the basis. These numeric values allow the items to be accessed. So then if you're not able to, how do you access items within a list? You access them using the numeric value. So we've called them the indexing. We've called it the indexing, and normally we use square bracket, then we now pass the numeric value. So I'm sure you're going to see that one in a short while as we do now the class practice. So those are the two properties that we have. We have collection within a square bracket. Number two, items are ordered. So which means that each item must be assigned a numeric value, that this one starts from 0. So this numeric value will allow these items to be accessed, okay? Then from there, I also want to mention about the third property here, which is equally very important, especially now for data scientists, is that the last property actually is that lists are mutable. So that is a very important aspect I wanted to note here before you even start doing the practices. So if I'm saying that lists are mutable, this means that, okay, items can be changed, because the opposite of mutable is immutable, which we saw yesterday, that is an item that cannot be changed at any given point. But in a list, items are mutable, which means that they can be changed using some methods that we call. Remember yesterday we talked about some methods. So for instance, just to expand on this one, the first thing you can do, if you want to add a new item, because lists are mutable, we are going to note about a method that is called to append, okay, or to insert. So we're going to note that there are those data types that are immutable. So you cannot add a new item. They cannot be changed after you've created them, okay? Then from there, I want you to see that you can also, so control question mark, within a list, you can delete basically by using either the delete operation or there's also something we'll call the remove function, and there's also something that we'll call the pop function. So enough with the theories. I want to share this one with you in case now you want to follow up in your class practice. So let me copy this one. I think I'll just copy direct. So these are actually the main properties that we have in a list. Okay, so let me share this one with you here. And then now from there, we can now move together. So those are the properties of a list. I've mentioned about list items are stored inside a square bracket. Let's always remember that one. Each comma separated. So I should have mentioned that one, but remember each item must be comma separated. From there, number 2, items within a list are ordered. Please always keep that one in mind. So therefore, each item must be assigned a numeric value for the accessibility purposes. And then finally, please always remember that if you're dealing with a Python list, then they are mutable. So this one means that you can actually change items within a list using some methods like append, insert. You can actually remove item by deleting them, removing them, popping them. You can actually update, and so on and so forth. So let's check out the notes that we have here. I think that is something I mentioned. So yeah, I think that was the first aspect that we saw here. So then we also have a nested list that you're going to do today. So a nested list is a list that is inside another list. So this nested list allows for organization of data in a more complex way, something that later we'll be calling tensor, or we are going to do a library called TensorFlow, which is actually a deep learning library. So a nested list will allow you to store data, to organize data in a more complex way. So we're going to see that nested lists are used for storing multi-dimensional data, the one that we're going to use in NumPy, such as matrices, tables, and so on and so forth. So then finally, you're going to see that we have some of the methods, like if you want to add a new item, we can append the item. If you want to add a collection of items, we can actually extend, we can remove, we can pop, we can sort, and so on and so forth. So lists are important, especially in Python, because they allow you to store and work with dynamic collection of data. And they are widely used in variety of applications, including data organization, implementing data structures like queues and stacks, and then holding results for computation. Due to the mutable nature of a list, we're going to see that lists are flexible and the efficient way to manage data during the program execution. So this is very, very important for me today, especially if now you're aiming to be, let's say, a data scientist or a data analyst. Then one very important data structure that we're going to interact with is a list. So from there, let's now check on some of the class practices that we have, so that now we can understand more the list even in more details. So the first thing that, which is normally the most confusing part, is that, can a list be empty? Yes, a list can be empty, and this can be done in 2 ways. Let me just copy this one for you, please. Yes, so we are starting from, are you able to create an empty list? So control question mark, empty lists. Yes, I think we're able to do that one by actually saying that empty list will basically call the list and then provide the bracket. So I want to do the 2 prints here. I want to print the empty list as well. So let's do this 2 here. So if you run these 2, we are going to note that this variable called empty list is actually it's actually a list, but doesn't have any data included there. Okay. So I'm waiting for this one to execute, and now you can see that the length. So if you call the length of the empty list, then you're being told that nothing is there. We have 0 items within an empty list, and this is actually how it looks like. Alternatively, because they have not indicated on the notes, alternatively, if you want to create an empty list, you can actually say that an empty list, something like this one here. So it's also an empty list. You can either use this function, this one, or you can also use the empty square bracket. So these 2 results to the same output, like that one. So you can, if you want to create an empty list, you can work with this function, or you can work with these square brackets without adding anything to the items within the square brackets. So I'm sharing this one with you. You try out, you can do even more examples just to understand. So that is where we started, empty lists. Okay, from there, I think in the class practice, we want to create 5 lists. So let's just copy these ones here so that now we can see them in more details in our class practices here. So I just want you to copy them here. Just copy them in a new code cell here. So make sure you're doing the practices so that now you are actually familiar even with the Google Colab environment. How do you add a new code cell? How do you run the codes, and so on and so forth? So please always keep in mind that a list, it's a data type that stores a collection of data inside the square bracket. I hope you can see that one. Each item being comma separated. So this could be the list of fruit. Because I want you to imagine, you cannot solve the collection in just one, in a single, like a variable, okay? Because alternatively, you could have said, let me just do them here, top here, just demonstrate something. If we didn't have a list, then we could have said fruit 1 is banana. This is actually now the alternative way. Fruit 1 is banana. Then you go to fruit 2 is orange. Sorry, I think I saw Gemini doing the right thing. I don't know where it went. So fruit 2 is, we have now the Gemini has done the right thing there. I hope you can see that if we didn't have a list, like this one here, then this should have been the option we have. The only option we have is we just store each and every item on its own variable. Like for example, the banana, we can call it the first fruit. It's the first item. Orange is our second fruit here. Mango is our third fruit here. And then lemon is our fourth fruit here. Now the disadvantage is, so I can actually say here that the disadvantage is, the disadvantage is that we end up creating so many variables, consuming a lot of memory. And remember, if you're consuming a lot of memory, then your program becomes slower. So okay, I just add it here. This makes our program slower. This makes the program slower. So remember, for any program to run in your computer, we normally use something called the random access memory. So if you want to use the random access memory within your computer, then you'll have to create a variable. Anytime you create a variable, the random access memory is used up. So if we didn't have a list, this is actually the option we have. I want you to imagine you want to store like 100 different types of fruit. Then this should not be the best way, because we're actually going to end up creating so many variables. I hope you can see the banana, a variable has been created for that one. Orange, another variable has been created for that one. Mango is the same. I hope you can see that one. Lemon is the same. So for us to avoid creating so many variables that will end up consuming a lot of memory and making our program run slower, then we now have an option of a list in such a way that we can actually say that banana, oranges, mangoes, lemons, all these ones are actually fruits. And because they are fruits, I can just create one variable. So I don't want to use a lot of memory to store now all the collection of fruit. Even if I have 100 fruits, they'll just be stored in one variable. And these are something, other programming languages, they're normally called arrays. They're normally called arrays, and they're very, very useful in developing applications. So as you can see that one, now we can even have more collection. Like if I want vegetables, so long as I put my vegetables here, as you can see, so long as I put my vegetables here, each being comma separated, then that should be a list. I have animal products like milk, meat, butter, yogurt. Web technologies, we can have HTML, CSS, JavaScript, React, Redux, Node, MongoDB, and so on and so forth. We can even provide some list of countries like Finland, Estonia, Denmark, Sweden, Norway. So I want to try and provide counties. So just write the class practice and create a list of 5 counties in Kenya. Okay, I'll start that one for you. I can start with Nairobi. So just try to do the practice so that now by the time the class ends, at least now you're able to create a Python list. So Nairobi is a county. Just put any county of your choice. You can have Nyeri. Nyeri is also another county here in Kenya. So you have Nyeri. Nyeri. I think another county I know is, which other county do we know here? Kilifi. Kilifi is a county we have here in Kenya. We also have another county, like, I think I've heard of Bomet County. Here in Kenya, we have a county called Bomet. And then finally, let me just have the last one. There is a county in Kenya here called Kiambu, like that one. So just try to do that one just to ensure that at least you are able to create a Python list. So the most common mistake here that I think I would add here, control question mark, the most common mistake is that developers forget to add the commas. So that is actually the most common mistake that most people do. They forget to add the commas. So if you forget to add these commas, then you're going to get some challenges here. So make sure that anytime you create a list, the first thing you do, you have the square bracket, and then now you put the collection of items, ensuring that after every collection, you actually add some commas. So after I've added Nairobi, make sure there is a comma. After I've added Nyeri, there is another comma. Kilifi, there must be this comma. Bomet, there must be this comma here. Now that Kiambu is the last item within that list, I don't need a comma. I hope you've seen that is actually the trend that has been following with the countries, with the web technologies, with the animal products, with the vegetables, and all the fruits. So I want to also try to add list of numbers. list of number, let's say Fibonacci numbers, and just even call them Fibonacci series. So it's a very interesting idea in maths where we have Fibonacci series. I just wanted to demonstrate that one using now the aspect of lists. So you can even have list of numbers. So Fibonacci series is actually a very interesting series whereby if you add 0, then you go to 1, then 0 plus 1, it's 1, then 1 plus 1 is 2, then 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8, 13, and now the series continue. So I've just wanted to add to show you that now we can even add a collection of numbers within a list. So it's not only a text. It can be strings, it can be integers, it can be floats, it can be complex, it can be any other data type that you want, so long as now each item that you add inside a list is comma separated. The most common mistake here is that please don't forget to add the commas. So any question from there, make sure you run this one, make sure you run this one, make sure you run this one for me here. And I hope now everyone is able to create now a list so you can have collections here. So if you're not there, I can actually provide this code for you so that now you can do it in your class practices. I'm sure now you're able to learn more from there. So I've actually added them here. I hope it's okay now from there. Are we together? Now let's proceed to the next part now. We want now to print the list themselves and their length, okay? So for example, if you want to say the fruits, how many fruits do you have? So to do that one, we will actually use the length function. So basically copy this one, because that is quite a lot. We cannot do it to save on the time. And then we can actually create a new code cell and then we add it here. So now we are saying that we want to print the list and then generate the length. So I think we can add something here that control question mark to get the length. We can use the len function. Okay, then we pass here the list here. So this one can actually generate for us the number of items that we have within a list. Okay, so for example, if I now say fruits, how many items do we have? We can actually run this one and see. I think now this one is self-explanatory. For example, fruits, the number of fruits we have. Okay, it's okay. So we can actually have the number of fruits as 4. For vegetables, you can actually say these are the vegetables we have. Then the number of vegetables we have is 5. The animal products we have is 4. The web technologies we have is 7. Number of countries we have is 5. So I want you to try and print the number of counties. So print here. Just try the class practices that I've actually added. So try to print the number of counties and also the Fibonacci series. So to just add this one, you can actually say now that finally, you can actually say that for you to see the number of counties we have, you can just say counties is the length of the counties, and then the Fibonacci series that we've added is the length of the Fibonacci series. So I'm just demonstrating here that if you want to get the number of items within a list, always work with the len function right here. So if you run this one here, let me just show you that one. Then you're going to get that now that the number of counties we have is 5. The number of Fibonacci series we have is 11 series. So if you count 1, 2, all the way up to 11. So that was the first practice. I hope it's now self-explanatory. That I think is self-explanatory, as you can see there. So I can add this one for you here. So I can add this one for you here. Oh, it's okay, Cliff. Then you can just follow the recording later. So then from there, we have those lists here. Actually, we can provide them right here. Then from there, we can go to the next part. I hope this one is okay. In case there is a question, please don't forget to pass them on the chat. So one thing that I've not mentioned here before we go to modification of list is that so long as you've created a list, there is some order that we have to follow. For example, if you have the list of fruits that we have here, each fruit is actually assigned a numeric value. Automatically, the first item in that list of fruits will be assigned 0. So this one will be assigned 0. This one will be assigned 1. Mango will be assigned 2. Then lemon will be assigned 3. So those are what we call the indexing values within a list. Okay, so anytime you add an item to a list, then the item should follow some order in such a way that it's assigned a numeric value that normally starts from 0. So if that makes sense to you, then now we can talk about modifying the list. Let's copy this one. I'm sure this should not be straightforward, but I'm sure maybe it would make much more sense here. So if I add the new, should not be here, sorry. If I had the new code cell here, just copy this one. So modifying a list, so I think I can add that to modify the elements within a list. So I can actually say that to modify items within a list, to modify items within a list, we can recall, so we can recall their index numbers, their index, let me just say their index values. They are recalled their index values. Okay, so for example, here, if we have our original list as fruits, we have banana, orange, mango, lemon. The first fruit, which is banana, will be accessed as index 0. Can you see that? So if you take this fruit at index 0, we can actually get the item. So the syntax is at this one here. You take the list, you put the square bracket, then you pass the index. So you pass here the index value. So for example, if I want to get the first fruit, I should just take the fruit and then I pass the index value here. The second fruit here, okay? So this should have been accessing, not modifying. This should have been accessing elements. This should have been accessing elements, accessing items in a list. So to access items within a list, then we recall their index values in this manner. So if I want to get the first item, I can just take that one at index 0 and so on and so forth. So if you run this one now, the first item, the first fruit that we printed here, let me just provide a space so that it makes sense. Like that one, like that one, that one. So in such a way that we can actually say that the first item, this one here, it's the fruits at index 0, and we are getting banana. The other one here is that the second item is at index 1. Now we are getting the orange. The third one at index, the last item. So the last item will be index 0, 1, 2, 3. So at index 3 here, we are now getting the lemon as the last item within a list. Alternatively, so this should be alternatively, this will be an alternative way. So alternatively, we can also get the last index by actually getting using the negative index. So in such a way that we can actually say that the last index is actually the length of the fruit minus 1. And I think it's the same. Yeah. So this is actually how you access items within a list. And I want you to try and access items within our counties. So let's try practice. So I want you to practice. So you can actually say access the Nyeri County in Kenya. So access the Nyeri County in Kenya. So where's the county? The county that we have here is, where is it? So we have the list of counties, can you see? So the Nyeri County is at index 0, at index 1. So if I want to access Nyeri County, what I can do, I can basically print, so can I even print the counties I have at index 1. So if I run this one, definitely I should be getting Nyeri County, okay? So always keep that one in mind. Now from there, we can actually say accessing using negative indexing. So then we talk about this one. This is very important. I can now pass it right here. Right here. So now we are talking about accessing item using negative indexing. So we want to access value using negative indexing. So this is actually something you're going to note is that a negative index extract or can access the last item from a list starting from negative, sorry, which should have been the number, -1. So what I mean here is that if I want to get the last item in this list, I should just say the fruits at -1, that should be lemon. And now the order follows. If I want to get the second last item, I should just say that the second last item is fruits at -2. So I want you to imagine this is -1, because now we're doing it in a reverse order. This is -2, this is -3, this is -4. So if I were to get banana, I can actually print here. I just say print the fruits at -3. So if I do -3, then that should have been -1, -2, -3. That should be orange. Should be orange. Then -4. You put -4 here. Now that one should be banana. So you can actually access the items in a reverse order using the negative index. That is very, very applicable. And we're going to see that one later in our subsequent classes. Then from that one, in case there is no question, so far so good. Yes, so I'm told to repeat that again. I can do that one. Grace? So I'm saying that the first way you can access items is that we say that each item is given an index number. This is actually index 0. This is index 1. This is index 2. And this is index 3. That is something we've seen here. Oh, we've seen that one here. Alternatively, you can actually access item in a reverse order using the negative index. So I think I can add that one here. So you can access items, you can actually access items in a reverse order, in a reverse order. That means that if I want to start from the last one, going all the way to the first one, then this should be -1. We don't have -0. I don't think we have -0. So we'll have to start from -1. We go to -2, we go to -3, we go to -4. And that is what we call negative indexing. I hope it makes sense. So you can either access it in the normal order or in the reverse order. So the normal order, this one is index 0, 1, 2, and that order follows. In the reverse order, this is negative 1, negative 2, negative 3, in that order. I hope now I've answered your question. In case you have more questions to do, you can also pass it on the chat. So for example, if I want to now access banana in a reverse order, because this is negative 1, this should be negative 2, this should be negative 3. Now banana is being returned as negative 4. And actually, that is what we got right here. I hope that one now makes sense. So to proceed, what about slicing? So we mentioned this one yesterday in a string. So we can also do it here in a list. So we can also slice a list. We can also slice a list. And we say that slicing items in a list, it returns a sublist or a portion of a list. Portion of a list. That is actually what we call slicing a list. It returns the portion of a list. So to do that one, we'll actually take the list and then pass where do we want to start slicing. So this is actually the start. And where do you want to end the slicing? Okay. For example, here, I have all the fruits. Let me just put a space here so that now this one makes sense first. I have the fruits, banana, orange, mango, and lemon. So if I want to see all these fruits, then I can just say, I want to start from index 0. Can you see? So that is where I'm starting. This is a start. Can you see? Then this is index 1, index 2, this is index 3. So to get all the items, then you'll have to print up to index 4, just like we did them in Python strings. Okay, so let me repeat that one. So this is the start, and then this is the end. So the start is where you want to slice, where you want to start the slicing. The end is where you want to end the slicing. For example, to be even in more detail, let's say I want to get, let me just make this one to be much more sense. So I want to only slice, I only want to return the orange. Sorry, what am I doing? So I want to return the orange and the mango. So I just want a sublist or a portion of a list that will only have the orange and the mango. So to do that one, I can basically print here I can actually print here the fruits that we had originally. Then now, I now return the sublist, such a way that I want to start from orange. So orange is at index 0, index 1. So you put here 1. Now, this is actually now the confusing part. The start is okay. I want to start from index 0, here 1, the orange. Then I want to end at index 2. This is 0, 1, 2. So for me to get up to index 2, then I'll have to go up to index 3. I want to demonstrate that one here. So I have to go up to index 3 like that one. So if I run this one, now you see that I'm now returning the list as now having the orange and the mango. So this is the most confusing part. If you are to get orange and mango, this is where we are starting. This is where we are ending. And because we are ending here, we will have to go to the next adjacent index so that it allows us to get these two out of that list. So I saw a very good question. Let me answer it. It was from Grace. Yes, you had a good question that why in indexing we start with 0, but in length we start from 1. Please explain. That is good. Yeah, that is very confusing. The length, we start from 1. Indexing, we start from 0. Let me start from the indexing part. That's a good question, actually. In computing, let me just go back to computing. Counting starts from 0. We normally start from 0, okay? So Anytime I add an item to a list, this one is assigned index 0. This is the first one. The next one is assigned index 1. And the order continues. I think that one now makes sense to you, okay? That one makes sense to you. I hope so. Now from there, now the length, because you've asked about the length, why do now the length start from 1? Yes, the length now. So for the sake of the length, remember, the length basically returns how many items do we have in a list. I don't know whether we have now that connection. The length starts by determining how many times we have in a list. So if I have an empty list, if I have an empty underscore list, something like this one, let me get the length of that one. It basically tells us how many items do we have in a list. So I can actually print here the length of this empty list. Let me see, the length of this empty list. Let's see what we get. We're being told that the length is 0, not 1. So I think it's 0 because we don't have any item in a list. So if I add something here like 1, now the length becomes 1. Can you see? If I put a comma and I add a new item, now the length becomes 2. If I add a new item here, the length now becomes 3. And now the order continues. So both of them, they start from 0 because in computing, counting starts from 0 in such a way that the indexing starts from 0 here, and the counting of the number of items within a list also starts from 0. So I hope I've answered your question. We are going to proceed now with, so we've talked about slicing. Please remember this one, that for you to slice an item, you'll have the start and you'll have the end. The start will be included, the end, we are going to include the next adjacent index within a list, okay? Now from there, we can actually go to now, so slicing using negative index and so on and so forth. Actually, it's the same. So this one means that now you're slicing in a reverse order, okay? So if you want to check whether an item exists within a list, let me talk about this one here in more details. I can now put it right here. So now we are saying that we want to check if item exists in a list. So to do that one, we use the membership. It's normally called the membership operator, which you actually have two. We have the two. We have actually, let me just say, membership operators. The first one is in. The next one is not in. That is actually the membership operator. You want to see whether something is in this one here. So the result is always Boolean, either true or false. I want to see whether you're in class today. The only response you can get is either you're there or you're not there. So it's Boolean. It's either true or false. Okay, sorry for that one. So it normally returns a Boolean. So by calling the membership operations, we're actually using the not, the in, or the not in, and it's either true or false. For example, I want to see whether, I think I should have used the other operation. So I want to print, so I want to see whether, let me just put a space here so that it makes much more sense. I can put a space like that one, or like that one. Now you can say here that I want to see whether the fruit banana, so remember it's a string, so you'll have to call it a string, banana, is in the fruits. fruits. That's the question. That is a condition. I want to see whether I have banana in fruits. Let me see what happens. The answer is true. It is true to say that banana exists in the list of fruits. That is what we call membership operation. So the reverse is that I want to see whether banana is not in. You can also say not in fruits. So if you run this one here, we're going to be told it's false. So what I'm saying here is that I want to see whether banana is not in fruit. Then you're seeing that banana is there. So this is false. Let me just first go with in. That one. Okay. Let's try a new one. Now I want to see whether we have lime. We have lime. So remember, we don't have lime here. In the list of fruit above here, we don't have lime. So now we are checking whether it exists in the fruit. Automatically, the answer must be, it must be false. The first one, banana exists in the fruit. Lime doesn't exist in the fruit. So the answer is false. Okay. So the answer for that one is false. Now from there, there's something else I want to talk about. Case sensitivity. Let's say I'm searching whether mango exists in the list of fruits I have. So to do that one, I want to print. So I want to print. So to print is to see whether it must be a string. Mango exists in the list of fruits. I want to see that one. I want to see whether this mango exists in this variable fruit. Let's see what happens. Now, for that reason, that is true. Can you see that mango is already there? But what if I say mango, that this is actually a different case sensitivity? Okay, let's see what happens. Now we are being told that is false. The mango that you are looking for, you are looking for a mango that starts with capital M. And the one that we have in that fruit, it's actually the one with lowercase m. So these are two different mangoes that you're trying to look for. So anytime you want to look for something within a list, then please always remember to check their case sensitivity, their cases. If it's the lowercase, then you'll always have to remember to look for the lowercase, like that one here. So if I were to search for the lemon, then I'll have to remember exactly type the name of the value within a list using the membership operation in or not in. Any question there? If not, we can now proceed to the next part. But I don't know, I'm forgetting. We'll be sharing this part with you so that now you can also be doing your own class practice. And I think that is how you learn best. From there, we also have appending. We also have appending. So let me copy this one here. Copy this one here. This one here. We paste here that one. So let me do that one for you here. So to append, just to explain more about that one. To append is to add a new item to the end of the list. So if someone is appending a list, then basically we are actually adding a new item to the end of the list. For example, so first of all, these are the lists we have. This is the original list. And because this list is mutable, so I can actually add here, this is possible. This is possible. This is actually possible because Python lists are mutable. So therefore, they are changeable. You can actually add a new item. It is possible because they are mutable. So now I'm allowed to add a new item. So in that order, in that order, if these are the original list I had, then I take that list and append a new item. So I should have actually demonstrated that one. You have to take your list, then should have been a comment. You'll have to take your list, then you put the dot. So anytime you put the dot, you want to call a certain method. So a method is a certain operation to be done. So I can actually call a method to append. And then we normally append now your new item. New item. You can actually put it here. So in this order, I have the original list of fruits. I want to append the apple. So now if I print that one here, I am getting that now lemon was the last item. Because I've appended apple, apple becomes the last item to the end of the list here. Okay. Then now, similarly, I cannot say also I want to append lime. So to do that one, if you run now, you get lime as the new item. Okay. In that list. So I hope that one makes sense to you, that if you want to add a new item to the end of the list, then you'll have to do the appending. Now from there, we go to the next part. So we're almost there. So please take note of all these functions we are learning here. The other item we have is here. We can copy this one. We can actually pass it right here. And actually pass it right here. So then the insert, it is normally used to add an item at a specific, so please remember the name is specific position based on the index provided, based on the index provided. So if someone is saying that you want to insert a new item to the list, then you want to add that item at a specific position. At a specific position, I think I forgot to mention, I forgot to share this one with you. This one, but it's already there. If you're not having the notebook. So let's pass that one there. Today, no more. There are no questions. I think we are good. Following closely. So I've been talking about appending, and now we're talking about inserting. What is the difference between to append and to insert? So we've seen that to append, normally add the item to the end of the list. That is what we've seen. Apple, the last item. Lime is now the immediate last item. From there, this one. Now the other alternative is to insert. So to insert is actually used to add an item on a certain position. So this is actually how you do it. So you normally take your list, then you call the insert function. Then you call the insert function. Now from the insert function, you'll have to start with the index. So the index is which specific position do you want to add the item? And now this is actually the new item. So this is actually how you can actually insert a new item. For example, let's say item, instead of new item, I can just say item like that one. So I want to take the list that I had initially. I want to insert an item at this specific position, and this is the item itself. For example, here I want to add apple at index 2. So here, index 0, index 1, index 2. So I want to add the apple right here. So this one will be moved to the next index. So if you run this one, let me see what happens. Now you're able to see that index 0, index 1 at a specific position, which is index 2. Here, we've actually added the apple. So if you say I want to insert lime at index 3, then at index 3, now we have index 0, index 1, index 2, index 3. Now we have lime. So the difference between to append is that to append just adds a new item to the end of the list. On the other hand, insert is basically you want to add an item at a certain specific position based on the index that you provide. So if you provide at index 2, this item will be added specifically at index 2. Similarly, if you provide index 3, then this item specifically must be added at exactly index 3. So index 0, index 1, index 2, exactly at index 3. Now we have lime added or inserted there. Any question there? So you can actually try that one and demonstrate whether it's working. And I think that is also self-explanatory. So I've shared that piece of code there. Then from there, we also have other more functions to do with lists. What about if we want to remove an item? So let's talk about the first one, remove. So I'm adding more nodes to them. So remove here. Now we are saying that if we want to remove an item, so this removes an item based on the name or the value. It removes an item based on the value, not let me just say the value. The value. So then you're going to notice that it returns an error. It returns an error in case the value is not present in the list. So it returns an error in case now you want to remove an item that is not present inside that list. So this is actually what you're saying. I have banana, orange, mango, and lemon. If I were to remove banana, just pass the banana here. So if you run this piece of code, you see that now banana has been removed because you passed the banana here. I think I should have provided that syntax. So you should take the list, then you remove based on the value. Yes, that one. So if I want to remove the value banana, then that's the case. If I want to remove lemon, then that's the case. What happens if I try to remove something that I don't have? Let's say I want to remove lime. And you can see that if I want to remove lime, you see, if I want to remove lime, it must return an error because I don't have lime. So that's something I wanted to mention, that if you'll always get an error in case the value that is not present in the list, the value that you want to remove is not present in the list. Like I want to remove lime and I don't have lime. So you're being told that X not in that list. So X means that the value that you want to remove is not present inside that list. So you have to be very, very careful with the item that you want to remove from a list. If I have lemon, then because lemon is already in that list, it should be now removed from that list. So the one common mistake we have here is now the spelling mistakes or the case sensitivity mistakes. So the lemon that is present inside the list and the one that I want to remove, they have two different cases in such a way that the lemon here is lowercase and the lemon here is uppercase. So if I try to run this one, then automatically this is also another error because I can even see that there is no connection between this lemon here with the lowercase L and this lemon you're trying to remove with an uppercase L. So this is actually one very common mistake that most people do, especially when they want to remove an element from a list. So why are we able to remove an element from a list? Because we've already said that lists are mutable data types. So that means that we can actually add, we have an opportunity to, we have the freedom to remove. Let's see other operations we have. Unless there is a question, maybe you can try that one. There's more detailed notes there. More detailed notes there, so I'll share that one with you right there. Then from there, you can actually proceed to popping them. So popping is another option. Popping is another option. Popping is another option to remove an item. So popping is another way you can remove an item from a list. So let's explain how that one works. So the first one here is pop it automatically. So automatically is something you don't do. Automatically removes the last item. So it uses the concept of LIFO, last in, first out. Last in, first out. Okay, so we normally uses the concept of LIFO. So which means that last in, the last item to be inside the list is the first one to be popped out. Yeah, LIFO. Yeah, like that one. Last in. So for example, here banana was the first one, orange was the second one, mango was the third one. Now lemon was the last one. So if you now pop, then it now uses now that concept of LIFO, where we now have the last in as the item that is popped out. I want you to imagine you're actually piling plates together. You're piling plates together. So the last plate that you pile should be the last one you can remove. So that is actually the concept of stacks. So this concept comes from the stack data structure. The LIFO concept comes from the stack data structure in such a way that the last item that we put in should be the last item in is the first one to be out. So if you want to see that one, e.g., you can actually talk about if you have a pile of plates. So the last plate you put is the first one to be removed, so that we're now able to remove the bottom one from that point. So that's actually the LIFO. So if I pop that one, that is the first scenario, pop. Alternatively, we can actually say pop, and then we pass the index. So it removes an item based on its index value. So that is what we call the pop function, where we're actually removing an item based on the provided index value here. So for example, banana, because it was the first item from that list, it was assigned index 0. So if I now say pop, I take the fruits here, I pop at index 0, then I should have removed banana. So if you run that way, that's why we're not getting banana right here. So that is actually the concept of pop, where you can just pop the last item, or you can pop an item based on its specific index value. Any question there? So I think I should add this one with more detailed notes. Please take note of that one. So I'm adding that one right here, so that now you can be doing more class practices together on your own free time. Then you also have the lead. So many, but you're almost there. We're almost there. So we have the lead. So the lead is actually self-explanatory. I don't want to dwell much on it. If you have a list, let's say you have the list of fruits here, and now for this list, you delete the fruits at index 0, then you're going to remove banana. So it deletes, it removes based on the index. It removes an item. It removes an item based on its index value, like that one. So for example, I want to delete fruits at index 0. So now we don't have it here. I want to delete fruits at index 1, 0, index 0. So then we have mango. So I want to see that connection. Let me first comment this one. So if you run this one here, So if you now say delete at index 0, banana should be out. Now we have a new fruit called orange mango. So from that one, mango is the now index 1. That's why mango is removed. So if I run this one here, it's actually a very common mistake that most people can do here. If I have this, if I say I've deleted all the fruits, and I want to now try and print now the fruits that I've already deleted, automatically that should be an error. The question is, you have deleted all the fruits. Why then do you want to print them? They are not there in the system. So I'm actually saying that the fruits that you're trying to view, it's not defined. It's not defined because you had already deleted them right there. Okay, so I hope that one makes sense. I think that was self-explanatory. We don't have to do more examples right there. I want to comment so that we avoid the error. Okay, now from there we can now move to the next part. If you're lost somewhere, always pass it on the chat. Then I would now clarify that one. There is also another widely used list operation, which is clear. So to clear is to remove all the items, but retaining the name. So we remove all the items, but retain the name. So the list becomes empty. That is actually the word. The list becomes empty. So initially I add fruits. Then I took all the fruits, then I cleared them. So now if I print fruits, I'm going to get an empty list. The opposite to that one is that for delete is that if you delete fruits, you're also going to delete the variable that it was assigned earlier. That's why we're getting the error here. So the difference with clear is that the name will be retained, but all the items will be cleared in such a way that we have an empty list. I think that one is self-explanatory as well. I'm copying that one for you to add in your class practice as you have now the more detailed notes that I've shared with you. So there, can actually move to the next part. Can you copy? Yes, you can actually copy in such a way that, let me just copy this one for you here. Yes, Don, you're asking for me to explain the error again. So I can do that one, just a minute. So now we do the copy. So I'm saying that if you delete fruits, you're also deleting the variable name that was assigned to those fruits. That's why it will actually tell you that the fruits that you're trying to print now here, it's not defined. Okay? It's not defined. So we normally don't delete fruits. We normally don't delete lists because it will actually delete even the name. It's like now you're removing everything from the computer memory. So I want you to imagine you can even go and delete all the students. Even the record that stored the students' names is actually removed. So now it's not defined anymore. Okay, the alternative to delete is clear. So I want you to see that clear will actually clear all the items from the list. So it makes it an empty list, but now the name is still retained. So that is actually the opposite. I hope it makes sense that the name will be retained, but all the items will be cleared. But if I now say delete, then I provide the variable fruits, then even the name is actually cleared from the computer memory. I hope now it makes much more sense to you. I paste for delete, please. I paste. Oh yeah, I paste this one for you. I'm not pasted. Okay, let me just paste that one. And you're going to notice that as much as possible, we'll be avoiding to use delete in case now we just want to clear everything, even in our memory. Okay, so we'll be avoiding that one as much as possible because it has one limitation. It will actually remove even the name from the variable the variable that you assigned. Now from there, I was talking about copying a list. So to copy a list is when you want to save a copy. For example, the variable name fruits here, but now you want to have another copy, okay? So I can create a variable called fruits copy, and now take this list and I copy them. So if I run this one, a new copy will be created in such a way that I can even print fruits. Yeah, that one. So you see, these are the same. So it's actually that you are maintaining a copy, something like a backup. So it's actually called the copy. So you can actually see, you want to see whether the fruits I have in this variable is the same as what I have in fruits copy, like that one. So if you run this one here, then you'd be told that that is true. That these variable fruits are stored the same exact values as the variable fruits copy. So mainly copy is to maintain and something like a backup. So I think that one is self-explanatory, as you can see there. Then you can talk about join. So join is when you want to join one list with another one using a plus symbol, like this one here. We normally work with a plus symbol to join one list with another one. So for example, here, we have positive numbers, like this one. Then you have negative numbers, like this one here. So now I want to join, and then you also have 0 here. So now I want to join all the integers. I start from the negative numbers plus 0 plus the positive numbers. So up to there, let me just first comment this one, and then I run. So if you run this one, remember the negative numbers contain this list here. So that is what we had. Then we actually joining them with 0. Remember, 0 was just a list with one item 0. So we joined with 0. And then now we've joined with the positive numbers. So it's actually what we call the join operation. So always remember it combines the list items. So it combines the list items using the plus operator. That's what we call the join. That one is also self-explanatory. I can share that one with you. For more examples, there's even one here that we have fruits and vegetables. I have fruits here. I have vegetables here. Now, if I want to combine fruits and vegetables, I can just say fruits plus vegetables. So if I now print this one, I'm getting all the fruits together with all the vegetables in one list. So that's actually what we call the join operation. So you can actually put it in your class practice and try it out. So it looks like I never added the join one. So that is the join. Then I can also share it on the chat for you to try out as well. Now from there, in case there is no question up to there, you can see there is no question up to there. So we can actually proceed to more operation where we can also talk about extend. So another alternative way to join two lists, you can actually extend them. I have the list of the first list, a new list. So I'll take the first list, then I will extend to the new list here. Okay. So if I run this one, let me see what happens. So this was the first one. I have extended to this one here. So it actually extends this one here to this one here. So it's actually an alternative way to join lists. Okay. Yeah, like that one. I think that one is also self-explanatory. Then you can also do the count. So the count is to count the occurrence. So it returns the occurrence of an item within a list. You want to see how many times an item occurs within a list. For example, I want to see how many times I'm seeing orange. I'm only seeing orange once. So the answer is 1. I'm only seeing the orange once here. If I have this list of ages 22, 19, so I want to see the mode, for example, not the mode, how many times the age 24 occurs, then looks like it has occurred 3 times. So normally count returns the occurrence of an item within a list. So how many times an item occurs within a list like that one. So we're almost done with all these list operations. From there, we have index. As you can see, the index returns the index value. So index returns the position of an item within a list like that one. So the index returns which position an item belongs to within a list. For example, if you say, I want to see the index of orange, then orange is at index 0, index 1. Okay, so if you run this one here, then I want to return the index of the age 24. So it actually return the first time it meets 24. So that's why it actually index 0, index 1, index 2. Okay? So that's why actually we have 2 here. So index returns the position of a certain item within a list. Questions? Yes, you have. So I think now we're almost done. Yeah, sorry for that one. So we're almost finishing now with all these operations. So looks like, let me just copy this one again here. So from there, we also have more operations like you can actually get the index, you can actually reverse. So you can actually reverse the items. We can actually reverse items within a list in such a way that now we'll actually get the opposite of how the list was ordered. Okay. Similarly, we can reverse. We can sort the lists. So this is actually the reverse. If the list was ordered starting that way, then the reverse is the opposite now. Okay. Yeah. Then from there, we also have, if you have numbers and then you want to reverse, so if you had started with 22, then 22 is the last one in that order. So you can actually reverse the list. At some point, you're going to notice that we can actually sort lists. So I want to focus on this one. And so now we finalize on all these list operations. I'm sure there have been quite a number. So to sort, you can actually sort items in ascending
or descending order. You can actually sort items in ascending or descending order. So if you want to sort items, if you have text, let me start with this one here. If you have texts, run this one here first, and then you sort them, they'll be sorted in alphabetical order. Okay? You just say sort, then it will be sorted in alphabetical order. Then if you do the sort reverse, then it actually reverse that operation here. Similarly for numbers, if you have these numbers and then you sort them, they'll be sorted in ascending order. I hope you see that one. So this will be very, very applicable in data analysis, because now let's say you want to get the top 10 students or the top 10 most selling products, then you'll have to sort all this collection in a certain order. So if you want to assert in ascending order, then you just have to say sort. And then if you want to send in descending order, then you have to say the reverse is true. So this is actually ascending. This is actually the ascending operation. And then this is actually the descending operation. And we're going to use that one a lot in our pandas. This is now the descending order that we use. So this is a descending order. Descending order finally. So I would share this one with you. Maybe you can try out. Now, in case you have any question up to there, you can always pass it on the chat. So I think now, so far so good, we have exhausted all the list data type operations. We have exhausted all the list data type operations. So in our tomorrow's class, we are going to do Python tuples and dictionaries. So tomorrow we'll do 2 in 1. We are going to do tuples and dictionaries in one class. Because now we are going to notice that tuples don't have a lot of operation because they are immutable. So we don't have so many operations to do in a tuple. So we are going to combine tuples and operation and dictionaries in one class. So up to there, I hope now you've understood the concept of Python lists in such a way that now we use them to store collection of items. And then we've noticed that they are mutable, which means that now we can manipulate information inside a Python list. Any question up to there? So if you have a question, then you can always pass it now on the chat, starting with Grace. So Grace, you're asking whether ascending or descending order, must we use true or false? Yes, that's true. That's a good question. Yes, we must use true or false. That's a good question. Let me just show you that one. So you want the reverse to be true. Yeah, so you want the reverse to be true. Then you'll have to use the Boolean. You'll have to use the Boolean. As much, you're actually saying that I want to sort the edges, but I want them to be in a reverse order. By default, if you sort these edges, it will go in ascending order. So if you say reverse to true, you want to now to do now the descending order. You want to alter that operation. Yeah, if you use VS Code for now, it will not be any challenging for you. For Python, you can still use Sublime Text or VS Code. If you are familiar with them, you can still use them, no problem. So reverse is actually a command. The reverse is not a string, it's actually a command. It's a parameter. We'll be calling them parameters later. It is a command to say that if you sort this fruit, I want this reverse them to be true. It is actually a command. Yeah. So for Karen, like if you're already familiar with using VS Code or Sublime Text, you can still use them. But if now we start on data science, you're still learning Python, which you can use any editor you have. But specifically for data science, it is always advisable to work with Google Colab. The only disadvantage that you're going to have for Google Colab is that in case you have issues to do with the internet, that is where the problem starts. But for now, if you're okay to use Sublime, of VS Code, and you know how to do all the setups and all the installation, then I'm okay with that one. Because it's actually more or less the same. Only that the outputs that you get, if I may demonstrate here, the outputs that you get are actually displayed in a terminal. They're actually displayed in a terminal rather than a markdown, rather than a notebook, sorry. So for example, let me just put this one here. So I say list.py. This is actually VS Code. And then I think it's taking time. I run this one here. So if you can actually see that if I run this Python, it will actually give me these outputs on the terminal. That is actually the disadvantage that we have. And that's why these Google Colabs are preferred for data science. But if you want to do software development, or you want to do, let's say you want to build a software, then we highly recommend VS Code. Yes, PyCharm is also good. It's actually one of the best you can use to learn Python. The only disadvantage that we'll have with PyCharm is that when we start on data science, when now you want to see, I wanted to show you that one here. Like here, I'm running on VS Code. You're going to notice that, I don't know, it's running. It should be running. Yeah, it's running. It's almost running. So it will be giving me the shell. So you're going to notice that the only disadvantage with all these other editors is that the outputs are actually displayed in a terminal. So you cannot present to someone something you've displayed in a terminal. And that's why we have Colabs, whereby if you run this code here, you're going to get an output exactly below it here, something like a notebook. That's what you call a notebook. We run a code, Python code, we run it here, and then you get a notebook here. But for the VS Code, I don't know why it's taking a lot of time. You see now, when I run this code, I don't get it in a notebook. I'm getting it in a terminal. And for the presentation purposes, this is not advisable. So what I can actually advise for now is that you can use Python, you can use VS Code and PyCharm and Sublime Text if you already know how to use them to learn Python. Okay, but now for data science, I will really advise we go with either if you have Jupyter notebooks or you have Google Colabs. Yeah, so the terminal output is what you're seeing here. This is actually what you're seeing here. So this is actually different. The same code that I ran here in a notebook. In a notebook, I'm getting actually the response exactly below that code, which is actually good for presentation purposes. But now with VS Code, as you can see here, I'm running this code, I'm getting the output in a terminal. This is what we will call a terminal. I'm getting it in a terminal. Yeah, so yes, Grace, you're asking between PyCharm, VS Code, and Colab, which is advisable to use? So my answer is for data science, I would advise Google Colab. But if you just want to learn Python, then you can still go with PyCharm and VS Code. But now for data science and data analysis projects, we'll actually be specifically using Google Colabs. I hope I've answered that one. So I can see no more questions. So thank you for having us today for this class. Thank you for having us today for this class. Let's meet tomorrow, same time. We now dwell further on Python, tuples, and dictionaries.